Today's video, we're going to begin with pulley system. And this is the first question we are starting with. The question says, the efficiency of the pulley system shown is 80%. Find the effort E required to lift a load of 1,200 Newton. This is the system shown. So we're looking for the effort required to lift this load of 1,200 Newton. So we'll begin with solution. Let's write out what we are given in this question. First, we are given the efficiency as 80%. So we're going to write efficiency as 80%. Okay. Find the effort. So effort is not known. We are looking for the effort. So effort is unknown. Required to lift a load of 1,200. So that is load. So our load equals 1,200. Okay. So what again are we given in this question? Looking at this block and tackle system of pulleys, we have 4 pulleys in the block and tackle system, and that gives us the velocity ratio. Because for pulley system, the velocity ratio corresponds to the number of pulleys in the system. And in this question, the block and tackle system has 4 pulleys. So the velocity ratio, VR, is going to be equal to 4, because we have 4 pulleys in the system. So we'll begin with our solution. Efficiency of a machine is mechanical advantage over velocity ratio multiplied by 100%. Now we are given efficiency as 80%, so we're going to put 80% here, equals mechanical advantage. We don't know what mechanical advantage is, so we are solving to get mechanical advantage. Velocity ratio here is given to us as 4, multiplied by what? 100%. So we can say 80%, which equals MA multiply 100% over 4. This percentage here can cancel this percentage. 4 in 4 is 1. 4 in 100 is 25. We're going to clean the board to continue. So we'll continue from here now. So we have 80 equals MA times, what we have here now is 25. MA times 25 will give us 25 MA. Of course, here is just over 1. So 80 equals 25 MA. That implies that if we divide both sides by 25, we have 25 MA. 5 in 25 is 5. 5 in 80 is 6. That gives us 16 over 5. And when we do 16 over 5, that is 3.2. So that implies that the mechanical advantage of this machine is 3.2. We know that mechanical advantage, MA, is load, the ratio of load to effort. And in the question, we are given the load to be 1,200, as you can see in the diagram. So this implies that this mechanical advantage, which is 3.2 here, equals the load. The load is 1,200 Newton all over effort. So I'm going to cross and multiply, and that implies 3.2 multiply effort equals 1,200. So to get effort, I have to divide both sides by 3.2. That makes efforts to be equal to 1,200 divided by 3.2, 375 Newton. So we need 375 Newton to raise this load. So it implies that our effort is 375 Newton as our effort. So that is option C, meaning option C is correct. So moving to the next question. This is another interesting question on block and tackle system of pulleys that we're going to solve. Okay, the question says the diagram represents a block and tackle pulley system on which an effort W newtons supports a load of 120.0 Newton. If the efficiency of the machine is 40%, then the value of W is what? These are the options. We're going to solve the question right now. So solution. Begin with what we are given in the question. The diagram above represents a block and tackle system of pulleys on which an effort. So we are given effort. We are given effort as W is not known to us. Okay, supports a load, so that is load. We're giving load to be 120.0 Newton. Okay, what again are we giving if the efficiency of the machine is this? So we're giving the efficiency of the machine as 40%. So the machine is 40% efficient. Then the value of W is what? We are looking for this. So what again can we get from here? Velocity ratio. Let's look at the diagram. Now for pulley system, I've explained in the first example, the velocity ratio corresponds to the number of pulleys in the system. So this is 1, 2, 3, 4, 5, 6 pulleys. Like 1, number 2, number 3, number 4, number 5, number 6. So we have 6 pulleys in this arrangement. We have 6 pulleys in this arrangement. That makes the velocity ratio to be what? 6. All right, let's go to the formula of efficiency. Efficiency of a machine is mechanical advantage over velocity ratio multiplied by 100%. So on substitution, this will imply, what is efficiency? 40%. So 40% equals MA over VR. What is our VR? VR is 6 multiplied by 100%. Again, this percentage go with this percentage. So we have 40 equals 100 MA over 6. Of course, we can reduce this fraction. 2 can go in 6 to be 3. 2 can go in 100 to be 50. So we have 40 equals 50 MA over 3. This is over 1. I'm going to cross and multiply. Before I do that, let me clean the board. All right, so we're going to have 40 multiplied by 3 equals 1 multiply 50 MA. That still remains 50 MA. So at this point, I'm going to divide both sides. 40 by 3 should give us 120. So we have 120 equals 50 MA. So I'm going to divide both sides by 50. So 120 over 50 should give me 50 MA over 50. This 50 goes with this 50. All right, and 0 go with 0. So we have 12 over 5. So this implies that our mechanical advantage is 12 over 5. Let's look at it. How many 5 can we get in 12? We can get 2, remainder 2, and 5 in 2 cannot go, add 0. 5 in 20 gives us 4. That gives us 2.4 as the mechanical advantage. Having gotten mechanical advantage as 2.4, we recall that mechanical advantage is load over effort. Okay, load over effort. This implies that mechanical advantage, which is now 2.4, we say 2.4 equals load. Our load is 120 Newton. So we have 120 Newton over effort. And when we cross and multiply, right, when we cross and multiply, we're going to have 2.4 multiply effort equals 120. We divide both sides by 2.4 so that we can get effort. And when I do that, effort will be equal to 120 all over 2.4. So our effort equals 120 over 2.4, and that is 50 Newton. So 120 over 2.4 gives us 50 Newton. So we need an effort of 50 Newton to raise this load. That means the value of W is 50 Newton. When we go back to our options, we'll go back to the options given to us, we discover that that is option D. So option D is correct.